Thank you, Sivia, and hello, everybody. Appreciate you taking some time to join us today. We are going to be looking at infrastructure as code security with Open Policy Agent and Regula with a focus on Terraform and AWS. But if you're using CloudFormation or Google Cloud or Azure, this should be very useful to you as well. I'll get going here. So quick agenda, introductions. We have with us is Curtis Meisey, VP of Engineering here at Fugue, who's going to really dig into developing custom infrastructure as code policy with Regula.
Thanks, Drew. Yeah, so this kind of sets the stage for what we're going to talk about today. We're going to get hands-on with Regula and Terraform, and I just want to talk about this slide a little bit for context. So Fugue helps with both infrastructure as code security and runtime security. And we're doing that with one set of rules, one set of policies. And Regula, which is our open source project, that is the policy engine that supports both IaC checks and runtime checks. And so I'm going to show you some rules that are compatible with Regula today. And you're going to be able to run those rules against both your infrastructure as code templates and runtime resources, which is really nice. We're going to focus on some developer workflows first, and actually working with .tf or HCL files. So you'll see the rules in action there. And the focus of this specific Lunch and Learn is on writing your own custom rules. And so we're going to write both a simple rule and a more advanced rule, and you'll get to kind of see the blow by blow there about how you can write and test a rule. And yeah, this slide kind of talks about Regula a bit more. Regula is compatible with both CloudFormation, Terraform, and other input types coming soon. So let's see, and yeah, as this says, we've got hundreds of predefined rules that Fugue has created and tested, kind of built into Regula. So just by installing Regula, you get all those ready to go. And like I said, we'll also test out writing our own rules. I'll call out one thing about simple versus, yeah, thanks, Drew. Simple versus multi-resource checks. We're going to see an example of both of those. Simple checks idea is we're going to test one specific resource in isolation, checking its attributes to see if they're secure or not. Multi-resource checks actually do basically a join to check multiple resources at the same time and see how they relate, see if the combined configuration of multiple resources is actually insecure in combination. So you know, we spent a lot of time working on making both of those approaches really, really easy to get going with. And then you can use this both, on a developer laptop while working in a Git repo, or you can integrate all this into your CI/CD. Cool. Thanks, Drew.
Yep.
Yeah.
Well, up my share here and let you take over.
Yep. Just a moment. All right. Drew, does that look all right? You should see my VS Code window.
Yep, looks beautiful.
Sweet. All right. So just to orient ourselves, I've got a Git repository here called the Superstore. In here, we've got a lot of different infrastructure as code templates going on. Some in CloudFormation, like this, and then some in Terraform, so with .tf files. And a nice thing about Regula is you can come into any Git repo with infrastructure as code templates, do Regula run, and you're off to the races. It will automatically discover all the templates you have in that Git repo and check them for security issues and misconfigurations. So really easy to get started with. We're going to be working in this particular subdirectory for this Lunch and Learn. And this is a small Terraform module that creates a Redis cache in AWS. So Redis is the open source caching database. Elasticache is AWS's hosted version of that, so you may be familiar with these. And we're actually going to be using a Terraform module here to provision that Redis cluster. And then we're going to be using Regula and custom rules to verify different aspects of this to check for security. All right, so that sets the stage with this Git repo that we're working in. I'm going to talk briefly about Regula and that setup for those of you that haven't seen this yet. So this is our Regula open source project. Like I mentioned before, Regula is Fugue's open source rules engine that powers all of this. I'd encourage you all to check out this page and give us a GitHub star if you haven't already. If you're interested in the project, we'd appreciate it. This walks you through a number of different things, including how to install Regula. So you can just do a brew install Regula if you're on Mac or Linux with brew installed. So that's probably the easiest way to get going. All right, regula.dev similarly is the Regula documentation pages. So you can browse this to see, among other things, how to write custom rules. So there's a custom rule development section in here that's really excellent. And this walks you through the process. Rules in Regula are written in Rego, which is the language from the Open Policy Agent project. And this is example Rego code. Rego is basically a query language. And what we're querying are resources we're defining in Terraform. And really they're JSON representation. So any attribute in a Terraform resource, we'll be able to check in these rules using Rego. And the gist of a simple rule here is we're going to say this rule pertains to something like an AWS EBS volume. And then we define whether this resource is allowed or not. And so allow is a simple true or false in this simple case. And in the simple rule here, we're looking to see, are the EBS volumes all encrypted? We're going to say, by default, we're not going to allow any EBS volumes unless input.encrypted is true, which is unless the volume encrypted field is set to true. So that's a simple check on EBS volumes. And as I mentioned, there's a whole bunch more documentation here about how to get up and running with that and write your own rules. And I'm going to switch back to VS Code and kind of walk you through that process. All right. So pop open my terminal down here. Regula version, is it? Yep. So with Regula version, we just check what we have installed. Our 1.2 release of Regula actually just came out this morning. A couple new features there, which I'll chat about at the end, maybe if we have time. All right. So as I mentioned, you can get started in a really easy way with Regula run. And that checks all the files in the repo. It mentioned no problems found. So right now we're in a good state. But we also haven't written some of our custom rules yet. So we're going to work on that. In this source cache directory, oops, that's actually where I was already. So we're in the Superstore repo /source/cache. So that's over here. We've got a handful of Terraform files in kind of a typical naming scheme. There's a variables file. Provider defines our setup of the AWS provider for Terraform using USEast2. Couple output values, and then the meat of it is in this cache.tf file. And you see all that here. We do a regular run in here. No issues right now. And I want to show real quick before we write a custom rule. I believe we have a built-in rule actually for Redis that's checking encryption in transit. So if you take this Terraform module Redis, they expose a bunch of variables, a bunch of configuration items. And so you can change these, of course. And there's a quick example of leveraging Regula built-in rules, right? So we got a rule failure now that I made that change. So our rule 105, Elasticache transport encryption should be enabled. That's a medium severity failure. And it points us exactly to where this problem was found. In VS Code, you can kind of command click on that link, and it takes you to where that module was used. And the cool thing is we actually trace down the location in the Terraform module that you're using to some information there. So you kind of get a call stack here when you're using Terraform modules, which is pretty handy. So we can switch that back and confirm that the problem goes away. And it does. So just to put one more point on this. So we're using Terraform modules here, which I suspect many of you using Terraform at scale are doing this. And we're using Regula to actually inspect kind of the usage of that module and making sure we're configuring it in the right way. Because even if a module is kind of secured by default, you could end up misconfiguring it when you're kind of instantiating that module. So we do need that extra layer of checking here, and that works really well. All right, so from here, let's start to write a simple rule. And when are we going to write our own rules for Regula? It's mainly when your organization or your team has some rules around what you want to do, or some, policy, organizational processes that you want to enforce. And that could be, putting requirements on your developers or requirements you're going to enforce in your CI/CD pipelines. And, these might be fairly specific to your organization or your team. Something like all resources should be tagged in a certain way. That would be a typical custom rule you might write. We're going to add our rules in this rules Terraform directory in the same Git repo. So I'm going to do just a super quick version here. I'm going to call this Elasticache example. Rego. And I'm going to copy some boilerplate I have here. So first we declare a package for a rule. We're going to name it something like Terraform Elasticache example. You can give your rules an ID just to track them. You define the severity you want that rule to have. Severities include like low, medium, high, critical are the typical ones. Give the rule a title. Why don't we just check for the Redis engine version being a particular value. 6.x, I think, is the latest version supported in Elasticache. So let's write a rule that basically checks that the latest engine version is used. Latest Elasticache engine version should be used 6.x. So this will, stop our developers, our teams from using a previous version of the engine. Input type, so that talks about what type of file are we going to be processing. If you're working with CloudFormation, you specify that explicitly. We'll not do that. Terraform is actually the default. So for resource type, we are going to be working with, it is Elasticache replication group is the name of this. This actually creates an Elasticache cluster, if you will. And so this is the start of a simple rule that works for that resource type. We can do a default allow false, which basically says disallow these resources by default. And then we're going to say when the input dot, I think it's engine version, equals 6.x. When that evaluates true, this rule should pass. And now let's see if I'll run Regula in the right way. No problems found. Let's say we go in here and change that engine version in our settings to 5.1.1. There you go. So there's an example where we've got a rule checking engine version for our Elasticache cluster. If the developer goes with 6.x for the engine version, it passes, otherwise it fails. And we saw that here where I did an override on the engine version and it's failing. And I'll switch it back to 6.x and it passes again. So that's a super quick example of a simple rule testing one resource at a time. If anybody has questions along the way, feel free to put them in the chat. So that's kind of a good stopping point right here too. I'll pause here just for a second if there are any questions.
Don't see any at the moment, but yeah, and please do pose any questions, any particular use cases that you might have that you're curious about how Regula would handle and fit into your workflow. Definitely let us know.
Yep. All right. Let's see. Let's move on to an advanced rule. Let's see. And I'm going to. So back to our use of the Redis module here. One of the things this is doing behind the scenes is creating multiple resources actually. Although it's one block here, the Redis module contains a number of things inside of it, and all that's kind of hidden from us. But that doesn't mean we can't write a rule against all of those things. So the rule I want to write with you all is that security groups we use with our Elasticache cluster should not allow traffic from anywhere. So we want to restrict traffic to, say, inside our own VPC on a private subnet. So relating to that, the Terraform module exposes this configuration item. And these are the CIDR blocks that are going to be allowed by security groups that it generates. This you may be familiar with. That's saying we're going to allow traffic from anywhere into the security group, which is a relatively vulnerable configuration, depending on how else you have your network set up. So we want to write a rule that fails when this value is present. All right, and so to do that, we actually need to kind of combine our knowledge of we have an Elasticache cluster with the knowledge of security groups and which are in use. And so that's the next example we're going to do. Elasticache security groups. So here is paste a couple lines of boilerplate in here. So I'm going to define a new package for this new rule. Define the metadata for that rule. Give the rule some new ID. This is going to be a high severity issue since the network vulnerability is pretty bad. We'll call it Elasticache security group should restrict access. And by specifying resource type multiple, that indicates that we're going to be using multiple resource types and we're going to look them up individually. And along the way here, I'm going to go back and forth between pasting some code in here and typing some out. In general, you can do a line like this to retrieve all resources of a given type. Elasticache replication group. So what this does, you can think of this like a query. So this Fugue.resources helper function we have in Rego looks up all resources of this type. And this is pretty cool. It basically, you can think of it as returning a list of instances of those resources. And this works both in Terraform HCL code evaluation as well as Terraform plan evaluation, which is one of the nice things about it. And then we're going to combine our knowledge of those replication groups with security groups. All right, so that gets us all security groups. There's actually one other type we have to care about for this rule, which are AWS security group rules. So the Elasticache module we're using uses all three of these types internally. What you do in an advanced rule to say whether you're going to allow or deny the resource is define a policy block. And that looks like this. You can do something like, I'm going to declare a variable called cache, which is replication groups. So what this syntax does is it says, I'm going to iterate through each replication group. That's what this array indexing expression does, and get each instance out of it. I'm just calling that cache. And then we can do something like define a policy, which is fugue.allow resource cache. So this is kind of the simplest form of a policy that should let the cache always pass. So we're just going to start there and make sure that works, and then expand it out from here. So we're actually not using these two sets of resources yet, just using replication groups. Now I'm going to do regular run, and that passes. One way you can see the specific output here. There are some other output formats that expose more information. There's a JSON output format among others. And so we can see here security groups. I'm going to do one additional argument. -u says to run only my user provided rules and not the built-in rules. So I'm going to do that so we have fewer rule results to look through. These are all the rule results shown in the JSON output. And this gives you a pass or a fail for each resource and rule combination. So this is kind of an output format you'd use if you were, taking the output of Regula and wanting to process it in your other tools, or with scripts, you can process the JSON output directly. All right. And here is a rule result for that specific rule we're working on now. And the rule result is pass, like we expected, because we're only allowing resources right now. So everything should pass. All right, let's intentionally make it fail now, just to test that that works like we think it should. To do that, we do fugue deny, and you can give it the resource you want to deny, which is that cache, and you can supply a message. And let's confirm that that fails. All right. So we confirmed our fugue deny call works like we want. And now we just want to kind of add on some conditions on this so that we allow or deny it in the appropriate situation here. In Rego, one of the interesting things you can do is define multiple blocks, and if the conditions you have in one of the blocks matches, that's the one that is evaluated. And so you can this is kind of like an if else, you can think of it that way. So we're gonna, by default, allow the resource. Let's see. So now we want to define our conditions, actually. I'm going to add in these other resource types again. And I'm going to define a helper function that looks up security groups corresponding to that Elasticache replication group. And here's a function that can do that. I'm going to call it find cache security groups. So you give it a cache, and the result is going to be a set of all security group IDs that relate to that cache. And there's a couple different ways you can kind of relate one resource with another in Rego. And the way I'm doing it here, which is one of the easy ways, is affiliating them by tag. So I'm basically saying we're going to use this application tag, and security groups with that tag that match the Elasticache groups with the same tag are known to be associated with each other. This syntax is a set comprehension syntax. It's a bit like a list comprehension in Python, if you've worked with those. And you're saying, I'm going to make a set of security group IDs here, where this is a security group, and where the security group tags for the application matches the tag from the cache. So if you're not familiar with list comprehensions, that might be a little bit mind-bending or hard to read, but as you can see, it's not much code. And if you read up on list comprehensions, they're pretty straightforward. So again, we're building up a set of all the security group IDs relating to that cache. That's the point there. Next, I'm going to define one other kind of a set called bad security group IDs, and I'll walk you through this. So here, bad security group IDs is going to be a set. We're defining it with a set comprehension again. So security group IDs where these things are true. So this you can think of like a query again. So we're going to iterate through all of our security group rules, where the security group rule is of type ingress, and where it has a CIDR block of all zeros. That's the one that we're trying to prevent. And we're going to associate the security group rules with their corresponding security group by ID. So this builds up a set of, sorry about that. This builds up a set of security group IDs that are known bad. And now we can kind of combine all this information together now. And we're going to do that like this. So let's find all the security groups associated with that cache. So now SGs are all the cache security groups. And we want to know if any of these security group IDs are in the bad set. And to do that, we can say SGs ampersand bad security group IDs. So that's a set intersection. And we can count how many match that with this. So basically, if any of our security groups are in the bad set, they'll be in this return set. And we're going to check that there are none of those, as in we only have good security groups. If we only have good security groups, then we're going to allow the resource. So hopefully I explained that well enough. That's the gist. And again, you can let me know if you have questions. So that's the good case where we're going to allow the resource. And now we want to do the bad case too. So I'm going to update this lower section. We're going to do a similar bit of logic. Get all security groups associated with the cache. We're going to check this again, but instead of equals 0, we're going to see if it's greater than 0, which is we do have bad security groups associated with the cache. And in that case, we want to deny the resource. So let's see how this does. All right, so the rule's failing, and let's sanity check that that makes sense. So we are defining a CIDR block of all zeros right now, so that is in a bad configuration. Excuse me. I'm going to switch that to a 10.0 address, say like this. And let's see if we did that right. Nice. So you can see, we've written a multi-resource rule that combines knowledge of security groups with knowledge of Elasticache and which security groups are used by Elasticache, and doing the right check here. So switch that back. We'll get our failure again. And if we did that right, we should be handling the case of multiple entries here too. I'm going to check that. I actually haven't confirmed that my code works with this, but it should. Yep, so that still correctly fails because there's at least one entry that's all zeros. And then this should pass. All right. So let's circle back and let me kind of breeze through this code one more time. If an aspect of my explanation is not quite clicking with you, let me know which part, and I can try to dive deeper to explain that. All right, so again, just to recap, this is an advanced rule that's checking, multiple types. We're getting 3 different types via these Fugue.resources queries: replication groups, security groups, and security group rules. And then we've written a couple helpers to basically associate those resources with each other. We're associating security groups with their corresponding Elasticache cluster. And we're associating security group rules with their corresponding security group. Looking for security group rules that are ingress only, and looking for ingress rules that have any CIDR block that is all zeros. And again, this array indexing operator looks for any CIDR block in that list that matches that query. And then we've defined both a passing case and a failing case for that policy. In the passing case, it's where there are no security groups that are in the bad set. And the failing case is where there are security groups that are found in the bad set. And we can customize our failure message however we want according to that. If you want to output, for example, the name of the cache or something like that, you can do that here with I believe it's sprintf in Rego. You can say Elasticache cluster %s is misconfigured. And then you pass in the arguments. I think that should work. Let's check. I'll switch this back to make it fail. And you can see we've got a customized error message now. So you can see that output is customized and %s is filled in with the ID of the Redis cluster. All right, that is the quick intro to 2 custom rules. Again, it's quite easy to use your custom rules in addition to all the Regula built-in ones. And that's kind of the default behavior, if you will. Or you can just use your own custom rules. In this example setup, the custom rules I'm working with are contained in the same Git repo as my IaC templates. That doesn't always have to be the case. For you, if you want to manage one set of custom rules for your team, you could have a dedicated Git repository for those, separate from your IaC templates. And that would be a good way to do it.
We did have one question, Curtis. David asks, do we need to write all of these policies, or do you provide templates? I don't know if it's a template to write policies, or maybe he might be referring to whether we have those pre-built policies. So I thought maybe you could take a minute, not necessarily to dig into the pre-built ones, but just to kind of describe what's out there. And we do have a previous Lunch and Learn that you can watch on demand that really digs into all the pre-built policies that we have.
Absolutely. Yeah, definitely the other Lunch and Learn content would be a great go-to here, and I will show you where to look though. So if you go to our GitHub repository, Fugue Regula, there is a Rego directory in here. And if you drill down in here, you can see all the source code for the hundreds of kind of built-in rules that we have. Rego rules, and then this is the input type, CloudFormation or Terraform, partitioned by cloud provider, and then by service. So let's go into Elasticache because that's what we were just working with today. Here is the encryption rule that we used ourselves. This was kind of the built-in rule that we started with. And yeah, one of the great things about this being open source, obviously, is that you can reference all these Fugue rules out of the box and take inspiration or borrow from them and customize them as you want. So that should help. I'll note that we also have some helper library code in here to make working with some types of resources a little bit easier. So for example, we have helper code to check for CIDR blocks that are all zeros and things like that. And you know, this helper function, for example, would have improved the custom rule we had just written because this one handles IPv4 and IPv6. So you can kind of peruse around there to see what helper functionality we have too to make writing rules even simpler.
Awesome, thank you, David. Let us know if that addressed your question. And do we have any other questions out there? Any particular Terraform or CloudFormation use cases that you're interested in understanding how Regula might be applied to those? So let us know.
And in the last minute or so, while we wait for any other questions to come in, I will show you one new feature that we just released this morning, actually, with this morning's Regula release. Now, you should see my VS Code window again. Let me know if that's not the case.
Yep.
I'm going to go back to the root of my Git repository here. And now you can define a Regula configuration file in your Git repository. And you can kind of set it up to include some default arguments that always take effect for any Regula command you run in the repo. I was actually using this the whole time to do a couple things. Basically, any Regula run option, which includes things like include additional Rego directories, you can basically specify ahead of time in your configuration file. So instead of doing a -i each time I run Regula, I say in my config file, I'm going to include my waivers.rego file and the rules directory. And now every time I run Regula in this repo, I automatically get those settings applied, which, you know, shortens your Regula command down to just, you know, the minimum, keeps your life easier. And so you can do things like, I'm going to remove my file and kind of start over. You can do Regula init. And then you can say things like include the rules directory. And it creates that .regula file for you. That's pre-configured now to do the right thing. And you can notice when you do Regula run, it says using config file. So that's how you know that's active. One of the reasons we did this is to make it, you know, dead simple for developers to make use of this, but also to give kind of predictable results for Regula when you're operating in CI/CD. So if you kind of always want to guarantee that a certain set of Regula arguments are used, you can specify them there in the config file, and those are the defaults. All right, I think that about does it for today.
Great, thanks. Why don't I'll if you can stop share, and I'll close up with the slides here. Thank you, Curtis. And you still have time to get a question or two in before we conclude. Let's see here.
Yep, and again, if you're interested in Regula and want to follow the project, please leave a GitHub star for us.
Yes, love the GitHub stars. Definitely helps us out. So again, kind of recapping, you know, with this approach, obviously Regula can be used independently of Fugue to check Terraform and CloudFormation security. But if you want to kind of combine that with Fugue, you can bring all of those policies that you're using for your infrastructure as code checks over to Fugue to check your cloud runtime environment with the same policies, avoid all those kind of conflicts and just headaches that can come with just kind of trying to use different rules and different tools for different areas of the SDLC for essentially the same thing. Some resources here that can help get you started. The Regula doc site is regula.dev. You can learn all about using Regula there. There's a lot of tutorials. You can find Regula on GitHub, as well as Docker Hub. And definitely, if anybody here is unfamiliar with Open Policy Agent, or OPA as they call it, it is a Cloud Native Computing Foundation graduated project, quite popular in the Kubernetes community. We took a look at it a few years ago and said, hey, this is really ideal for kind of the infrastructure as code and cloud security use case as well. And so we've really built a lot of our policy as code tooling, Regula, as well as kind of the engine under the hood with Fugue based on OPA. So you're really kind of, you're investing in an open source framework for policy as code by going with OPA. So we're big fans, we're contributors there as well. Definitely check that out. And then with Fugue, definitely reach out to us if you want to, get a one-on-one session with Ricardo Green or one of our solutions architects to kind of dig into your specific use case, spin up Fugue and get an actionable cloud compliance assessment for your AWS, Azure, or Google Cloud environment in 15 minutes. And I think we give you a lot of information that helps you bring your cloud into compliance very quickly and prove that to management and auditors every day going forward, and kind of just automate away a lot of those issues and those headaches, and kind of focus a little bit more on, why you're really here using the cloud, which is to build cool stuff. So definitely reach out to us. Would love to chat, and please do give Regula and Open Policy Agent a look. So thank you very much. Thank you, Curtis. Thank you, Sivya. Appreciate it. And thanks everybody for taking some time with us today. Really appreciate it.
Thanks all.